Hi everyone! For this activity, we are going to talk a little bit about how to make a track for our plane. So when we take a look at our plane, we can actually animate this, right, to be able to move forward and spin its little propeller down a track. All right, so that's our goal. To create this piece, we have a drawing that shows our cross-sectional view. So we're going to create this shape in our own part studio, and then we are going to extrude this track to 35 inches long. So we're going to start here by creating a new part studio, and we will create a sketch on our front, either choosing our view cube to view normal to or hitting our N key to view normal to. And we have a couple options here. We can create the whole shape, we could create half the shape and mirror it, and that is the choice that I'm going to do here today. So I'm going to choose our line tool and choose our construction line option. And just create a construction line down the center here. And then I'm going to choose my line tool again. All right, and we're going to make a half shape. Okay, we just want to make sure that all of our lines are perpendicular to each other and are in line with each other. Okay, so we can drag our cursor across and down to make sure that each piece lines up in line with itself. Okay, I'm going to choose escape to take the line tool off of my cursor. Right, then we just need to dimension. Right, we'll dimension our overall distance from the furthest out point to our center line. Remember, if we keep our cursor here, it would only do half. If we bring our cursor across, it'll give us the entirety of that dimension. All right, this we want to be 3.25 inches. All right, from our multi-view, we also have a distance or a height of this edge of 0.45 inches. We have the depth of this little gap is 0.2 inches. Then we have the width of this gap is 0.5 inches. If you notice, we don't quite have everything constrained since we still do have blue in our drawing here. So we need to make sure that the tiny little piece here, the gap between our edge and our dip here, this needs to be 0.15 inches. All right, now we have a fully constrained sketch. We do need the other half of this though. So we are going to choose our mirror tool. It says to select a mirror line. That's going to be our center line here, that construction line we made. And then select entities to be mirrored. We can go around and we can click everything we want, or we can click and drag our cursor to select the whole thing. Right, as you notice, it automatically mirrors and then shades in our shape since it is now a closed loop. All right, we can accept our sketch. All right, I'm going to right click outside and hit isometric, or you can choose your corner view. Right, and then we are going to extrude this, like it said in our notes in our drawing, to 35 inches long. Right, so we'll extrude this to 35 inches long. This you could do symmetric if you'd like, you could do blind if you'd like. Either way will work for our purposes. I'm going to accept the sketch, choose P to hide my planes, and here is our track. Okay, so I'm going to go back to my assembly. All right, and we need to now add our track into this assembly. So if we choose our insert option, we can scroll down, find our track, okay, insert it into our assembly, and accept. All right, I tend to like to attach whatever main portion of our assembly to the origin. So I'm going to click somewhere along this object to open up our try orientation set of arrows. I'm going to click and hold that center dot to snap it to the center of this piece. We're going to move that to the origin, and then I'm going to right click and fix that just so this piece is stuck. and the rest of our plane can move around. All right, I had already had the plane approximately in the right spot, but we can still move this around. But what we now need to do is actually constrain these two together. So what we're going to do is we actually want to use a slider mate, and we're going to turn this all the way around to look at the back of our objects. All right, we want to mate the center of our back edge with the center of our wheel block. Okay, if you notice, it drops just the wheel block down for right now, and that's okay. But we do need to offset this since we want the plane to be above the track and not moving within the track. Okay, so this is going to be an offset in the Y direction of 0.8 inches, approximately. We're going to accept this. As you notice, it moves the whole plane down, kind of attaches it to the track here. Okay, if we go back to our isometric view, all right, it's approximately where it needs to be. Right? But if you notice, if we animate the slider right now, okay, when we hit animate for our slider and change our distance, remember 1 inch is super tiny for this since this is a 35-inch piece. Right? If we say maybe 30 inches just so we can see what happens, when we move this now, our propeller isn't going anywhere. Nothing's happening. So we do need to actually add in a couple more steps to make sure our propeller moves with our plane. So what we will do is it's called a rack and pinion relation. So we're basically going to choose multiple of our other mates to work together at the same time. If we choose this rack and pinion mate, well, not mate, relation, all right, we choose our mates in here. So the first mate we need to choose is the mate, the revolute mate for our little propeller. So within our mate features, you may have 1,000 mates like I do. All right, usually when we went through these, you only should have the 2 revolutes for your wheels and the revolute for your propeller. Right, so I'm going to choose the one when you hover over it, it highlights, it shows a little curve around our propeller. We'll choose revolute. Then I'm going to choose the slider we just created. Distance per revolution is basically, in our case, how many times or how much it's going to rotate, all right, per distance along the slider. We can leave this at 1 inch for right now. Okay, once we accept this, now if we go back and reanimate our slider, we will notice we now have a working propeller. We could do something very similar to the wheels, but right now most of y'all's wheel files are smooth, so we would not see any of the actual movement. So at that point, we're not going to worry about doing the same type of relation for your wheels. But for our next activity, you're ready for that. All right, so take some time, try this out, and let me know how it goes.